Hey, in this video, I'm gonna just go over some operations functions in R. Basically, R provides a wide range of mathematical and logical operations, and they are essential for data analysis and data manipulation. Okay. The first, let's just go over some basic mathematical operations. For example, the basic arithmetic operations, addition, subtraction, multiplication, division, exponentiation, modulo, and integer division. Okay, so basically, let's just look at a few examples here. So here, 5 plus 3, so that's 8, right? And 10 minus 4 is 6. 6 times 7, that's 42. Division, 15 divided by 3, that's 5. Exponentiation, 2 to the power of 3, that's 8. And the modulo, 10. So this is, um, the symbol is a little bit like 2 percentage symbols there for modulo. 10 divided by 3, what's the remainder here? It's 1, right? Integer division. So here is percentage sign and then slash and the percentage. Okay, so this is 10 divided by 3. You got 3 there. Okay. Okay. Also, there's some very commonly used mathematical functions. They include the absolute value, ABS, and square root, SQRT, exponential, EXP, logarithm, LOG. This is the natural logarithm, okay, with base E. Okay. And logarithm with base, you get log of x and then the specified base. The rounding function, you got a round, and you got a floor, and you got a ceiling. Okay, so let's look at some examples. So absolute value of -7 is 7. Square root of 16 is 4. Exponential e to the exponential of 2, so that's 7.38956. The natural logarithm of 10, that's 2.302585. If you want to do a logarithm with base 2, then you have to specify base equal to 2, and this gives us 3. Rounding, okay, so you got 3.14159, you want to round it to 2 digit, so it's 3.14. And if we want to find the floor, that's the largest integer smaller than 3.8, so that's 3. The ceiling, that's the smallest integer that's larger than 3.2, that's 4. So we also have logical operations. These are to compare values and return true or false. And these are used a lot in like if, then, else, if, those kind of conditional statement to control the flow of the program. So here we can do comparisons operators. You get equal to, or not equal to, greater than or less than, greater than or equal to, or less than or equal to. So let's try 5 equal to 5. Yeah, of course that's true. 5 not equal to 3. That's true. 10 greater than 7. That's true. 4 less than 8. That's true. Greater than equal, so 6 greater than equal to 6, that's true. 3 less than equal to 5, that's also true. Okay, and then you can actually have logical operators. Basically, you have and you have or you have not. Okay, and pay attention to the and. You have say and then you have double that and sign. So give you whether it's like have multiple comparisons or just compare like two values there. Okay, we'll see in an example. So here let's do an AND example. So true and false. So that's false. True or false. That will give you true. Not true, give you false. Okay. So if you have vectorized logical, so you get AND, logical AND. So you get true, false, true. You want to have that. And see true, true, false. Then you get basically look at the kind of like component wise. So the first one is true, true, so you get true. Second one false, true, you get false. Third one true, false, you get false. Okay. Or you get vectorized logical OR, so you can do the true, false, true, then or true, true, false. And you get all true. Okay. Short circuit AND, basically you're saying true and false. This must be both true, but then it's false. Short circuit or you got two vertical bars here, true or false. It's true. Okay. And then you can have logical functions. You have any or all. Any returns true if at least one element of vector is true. All returns true if all elements of vector are true. Okay. So for example, you get any, you get false, true, false. Returns true. Okay. But if you use all, then you have true, true, true. Of course, you get true. So the conclusion here is these mathematical and logical operations are fundamental to working in R, providing the tools to perform calculations, make decisions, and control the flow of code. Mastery of these operations is essential for efficient data analysis and programming in R. Okay, so these are very, very basic, but very important. Thanks.